Hey guys, so here's your guys' part 3 of your guys' 21-22 Math 3 spring final. So when you guys do problems like 29 and 30, the goal is to get the same common base. And then once you guys get the same common base, then you guys set the exponents equals to each other. So for 64 and 16, they both have the same common base of 4. So 4 to the third power is 64, and then there's still the 3p that exists there, equals 4 to the second power, 4 to the second 16, times negative p minus 1. And then we simplify 4 to the 9p equals 4 to the distribute negative 2p minus 2. So now they got the same common base, so then you set the exponents equals to each other. 9p equals negative 2p minus 2. Add 2p to both sides, solve for p, and we get 11p equals negative 2, divide both sides by 11, and p is equal to negative 2 over 11, which is going to be b. That's going to be b. Okay, so again, number 30. To solve, we need to get both of these to be the same common base. So 2 to the negative 3x equals 1 over 2 to the 5th. 2 to the 5th is 32. Now remember to put this not as a fraction and put 2 to the 5th to the top, you guys. That's 2 to the negative 3x equals 2 to the 5th, but this exponent now becomes the opposite, negative. And then we set now that the bases are the same, we set the exponents equals to each other and we solve for x. X equals positive 5/3, which is C. That's C. Okay, so there's those type. 31, so for here you guys, now again, you guys got to get the same common base, and then we're going to set this equals to x. So we are going to do this log form. We have this log form, and we're going to convert it to be in exponential form. So we're going to make this into exponential form, which is b to the x power equals a. So we have this form, and now we're going to convert it to be an exponential form. So what we have is, this is the base. So to convert this, so everyone, this is in log form. Compare and contrast, that's in log form. We're going to make this look like this form right here, exponential. So take the base, which is 7, raise it to this one, which is x, and make it equals to this one right here. That's how you guys convert from log form to exponential form. Take the base, raise it to this power, and set it equals to this right there. And then from here, all you guys gotta do is just get common bases on both sides. So 7 to the third is 343. 7 to the x equals 7 to the third, but now this is the opposite, negative 3. Now that they have common bases, x equals negative 3, which is C. Okay, 32, same deal. This is log form. Set this equal to x, and we're going to make it into exponential form. So take the base, which is 2, raise it to this, which is x, and set it equals to this number right here. Log form, converted it to exponential form. And now let's solve for this. Get both sides to be the same common base. So 2 to the 6th power is 64, and then since they have the same common bases, x is equals to 6. Okay, now we have expanding and condensing. So if you guys forgot what expanding looks like this, and when you expand it, you get log base b of m plus log base b of n. So going from left to right, that is what you guys call expand. When you guys go from right to left, getting it into one log, that's what you guys call condense. So we gotta expand this. So we're gonna get log base 2 x to the 6 plus log base 2 and y to the 3rd. And again, you can't have these exponents there, so you guys have to put both the exponents in front of the logs. That's your guys' power rule. So 6 log base 2 of x plus 3 log base 2 of y. This is how you guys expand. And our answer is going to be D. So again, make the 1 log become 2 log with an addition sign because there's multiplication happening in between here. And then get the exponents and put them to the front. Okay, 34. So here's another formula for you guys. We got log base 3 of 6 to the 2nd over 11 to the 4th. So when you guys have this, so we gotta make this, okay, let me write down the formula. So if you guys have division within a log, when you expand it, it's going to be log base b of m minus log base b of n. So when you guys expand it like that, you're going to get, so when you guys do division inside of a log, then it's going to be subtraction. It's going to be subtraction in between the two logs. So right now we have this, so when we expand it, it's going to be log base 3 of 6 to the 2nd minus log base 3 of 11 to the 4th. And then to finish it off, we just put the two exponents to the front. So this is what it looks like to expand it all the way. So then our answer would have been C. Our answer would have been C. So there's expansion, and now you guys, for these next ones, we gotta condense it. So it's basically doing the reverse now, doing the reverse. So let me bring this down so you all can see. There's that, and here is that. And again, left to right, that's when you guys expand it, getting multiple logs. When you guys go over here, you get one singular log. All right, so now we're condensing. So in order to condense this, you guys look at the formula. It has to be log plus a log. So they don't have the coefficients, so what we need to do is bring both these coefficients to the exponents. So log base 5 of x to the 4th plus log base 5 of y to the 2nd. Notice now it's log plus a log, you guys, now. So now we can condense it into one singular log. Log base 5 of x to the 4th times y to the 2nd, which is D. 36. Again, we need to condense it, so we can't have the exponents, so we're going to put these as exponents. Make the coefficients into exponents, so log base 2 of 12 to the 6th minus log base 2 of 5 to the 30th. And now we got a log minus a log, which means we can condense it into one log, but then since it's minus, we're going to divide the two from each other. 12 to the 6th divided by 5 to the 30th, which is C. That's C. Okay, so there's condensing and expanding. Okay, now we have solving equations. So when we have a log equals a log, so let's do log base A of m equals log base, we'll make that B. So when it's a log equals a log, you guys, all you have to do is just set the two insides of the log equals to each other. So because this is log base 5 and log base 5, all we have to do is just set both of these equals to each other. 4x equals negative x plus 5. And then we just solve for x. Add x to both sides to get 5x equals 5. Divide both sides by 5, x is equal to 1. Now the thing with logs is you have to plug this back in and make sure into the original and make sure the inside of the log function is not a negative or 0. And if we plug in negative 1 into both of those, they both become positive. So this x equals 1 is fine. But if you guys plug it into the original and it's not, and it is a negative or a 0 on the inside, that's what we call an extraneous solution, which wouldn't be an answer. So let's do 38. Notice it's a log equals a log, so that means we just set the two value quantities inside of the function equals to each other. And then from here we just solve for a. I'm going to get my variables on the left hand side and get my constants to go on the right hand side. A equals to 0, but then when we plug in this 0 into here, for both of them it's going to be log base 16 of -4. So watch, if you guys plug in 0 into here, 0 minus 4, that's -4, that's log base 16 of negative number. That is not allowed. So that means this can't be our answer, which means we got no solution. So you guys have to plug any answer you get from log equation, you gotta plug it back in to make sure that you don't get a negative or a 0 on the inside of the logarithmic function. Okay, 39. Log equals a log case, so set the two insides equals to each other. And then we solve. So I'm gonna get, since it's a quadratic, I'm gonna set the whole equation equals to 0. So we get this, and now we factor this. So what two numbers multiply to -42, but when we add it gives you positive x. That's x minus 7, no, x plus 7 times x minus 6. So x equals -7 and x equals to 6. But again, we have to plug in both to make sure that no negatives or zeros are inside of the log function. If we plug in 6 into here, the x's, you guys, that's going to be fine because it's going to give us nice positive values inside log. But if we plug in the -7 into here, you guys, this is log of a negative number, which is not allowed. So that means -7 is not allowed. Our only answer could be 6. And why am I not? Oh, I'm doing it to the wrong function. Sorry, not this one. Sorry, we're talking about 39. So if we plug in 6 into here, you guys, it's going to give us nice positive answers. And we plug in -7 into here, I believe we get nice positive values as well. So that means both of them are going to work. So it's C. It is C. Yes, both of them will work. 40. So again, log equals a log, so we set both equations, or inside the logarithms, equals to each other. Because this is a 4x squared, you guys, and this is a 3x, I'm going to move it to the right-hand side, just so that my leading coefficient is positive. So I'm moving everything to the right-hand side. And now let's factor this using x method. X minus 10 times x plus 5, you guys, is equals to this. That's the factor. So x equals 10 and x equals -5. Now, when we plug in both of these back into the original, these both also work. If we plug them both back into the original, both of them turn out to be positive. So it is going to be B. Okay, 41. Now with 41, this one goes back to getting a log function and getting it and making it into exponential form. So notice, you guys, on the left hand side of the equal sign there's logs, right? But on the right hand side it's a number, which means we're gonna have log form, and once we get log form we gotta convert it to exponential form. So let's condense this. Log plus a log, that means we can condense it to one log, but then this and this get multiplied to each other. So we got log base 2 of x squared plus 14x equals 5. Now here's the part. We have log form, right? we gotta convert it to exponential. So take the base, which is 2, raise it to this number, which is 5, and set it equals to this right here. X squared plus 14x. 2 to the 5th is 32. Set the equation equals to 0, so minus 32 to both sides. And we get 0 equals x squared plus 14x minus 32. Factor that, and we get x plus 16 times x minus 2. So x equals negative 16 and x equals to 2. But then you have to plug in both of them into the original to make sure you guys don't get any extraneous. And if both of these are negative 16, it's going to give you guys a log of a negative number. So this one's not allowed. If you guys plug in 2 into here, it's perfectly fine. So your only answer is x has to equals to 2. Last one, 42. Again, let me drag it over. This is going to be a log equals a... This is going to be a log, converting it to an exponential form because I only see logs on the left-hand side and a number on the right-hand side of the equal sign. So we got to condense these first. Log base 3 of 5 times x plus 6 equals 1. So we got log base 3 of 5x plus 30 is equals to 1. Now we have log form. Now we gotta convert this log form to exponential form. So take the base, which is 3, raise it to this number, equals it to this. 5x plus 30. And then we just solve for x. Subtract 30 to both sides, and divide both sides by 5. X equals negative 27 over 5. And if we plug that back into here, you guys, negative 27 over 5 will give, and plus 6 will give us a positive value. So A is our answer. And the answers are all down below for you guys to check. So good luck, you guys, and we're going to review this in class. So study hard and, last push, okay? Good luck. Peace.